Hello, I'm Dua Khalifa, a research associate from the Department of Industrial and Systems Engineering at Khalifa University. In this video, I'll be demonstrating a simulation model for a multimode cargo transportation system. The model we've developed is generic and can be adapted for any desired network layout, including its geographic location. All the input to the model, including the network layout, is consolidated into one Excel workbook. So, to utilize the model for any scenario, all that the user needs to do is to alter a single Excel file that will be imported to AnyLogic. And with one click, the user will run the model and receive the outputs. The main goal of the model is to simulate cargo transportation. There are four main types of transports: road, rail, water, and air transports. Our model includes the first three. We consider trucks and carriers from the road transport, trains from the rail transport, and vessels from the water transport. We assume that the cargo type transmitted by all the transportation modes in our model are packages. In a nutshell, our model assumes having consolidation centers, trucks, trains, and vessels that transport cargo orders between the consolidation centers. Regarding the cargo orders pickup and delivery, we assume that customers can either drop their cargo orders for shipment at a consolidation center or request a carrier to pick up the orders and deliver them to consolidation centers on their behalf. Now let's take a look at the model. I will demonstrate a multi-mode cargo transportation system within the United Arab Emirates. Now let's run the model. The first thing we see is the United Arab Emirates map. Within the map, we can see consolidation centers with different colors located across the UAE. If we zoom in a bit, we can see trucks. Each truck follows a predefined schedule route such that each stop within the route is a consolidation center. The navigation to these centers is achieved by following the roads provided by the GIS map. We can also see trains. These trains follow a user-defined path, which is a collection of GIS points. Some of these points are actually consolidation centers, where a cargo order can be picked up or dropped off by a train. In this model, we have 4 train paths, with 1 train per each. We also have 1 vessel path and 1 vessel that are created in the same manner trains are. Both the trains and vessels' movements are based on timetables. In this model, there are 2 ways to receive cargo orders at a consolidation center. The first way is by customers dropping off the orders at the consolidation center, and the second way is by couriers picking up the orders from customers' locations and delivering them to the consolidation centers. For more functionality, we assume that an order may visit some consolidation centers before it reaches its final destination. For each consolidation center that needs to be visited, a valid transportation mode would be specified to be taken to reach that consolidation center. The main purpose of this simulation is to evaluate different scenarios, policies, strategies, and optimization algorithms. In our model, the user has the freedom to, with respect to consolidation centers, is to determine the number and location of consolidation centers. With respect to trucks, determine the number of truck routes, consolidation centers within each route, number of trucks per route, and truck schedule. With respect to trains and vessels, the user can determine the GIS paths of the trains and vessels, the number of trains and vessels per route, and the train and vessel schedule. With respect to cargo orders, the user can determine the location and the number of the circular regions, as well as the arriving rate for both types of orders. For couriers, the user can determine the number of couriers and their parking location. Now let's take a look at how the Excel workbook looks like. The Excel file consists of 18 sheets. I'll take you through them briefly. The first one is the consolidation centers. It contains all the consolidation centers' names, latitude, longitude, rotation, and color. The order arrival rates. This sheet contains an order's origin and final destination, its arrival time, and its arrival rate per week. We also have circular regions. This sheet contains the latitude and longitude of the points of several circular GIS regions with different diameters. The random parcels will appear randomly within these regions based on an arriving rate. In the random order's arrival rates sheet, we have the number of the circular region an order would arrive at, besides the arrival time and the arrival rate per week. In the truck routes sheet, we have all the information related to the truck routes, including the route's number, name, the color of the truck that belongs to that route, as well as the starting point of the route. The same thing applies to the train routes and the vessel routes. Moving to the truck route consolidation centers, we can see the consolidation centers for each truck route along with the travel time and stop time. The same thing is for the train and vessels. Next, we have the vehicle schedule. For every route, it holds the departure time of a vehicle or a transportation mode. Each row means that all the route stops should be visited within the departure time specified and the departure time of the next round. Next, we have the truck sheet. In this sheet, we have all the information related to trucks, including their ID, the route they belong to, their capacity, the average speed, the fuel consumption, and the CO2 emission. The same thing is for the trains and vessels. The carriers have a similar table, but instead of the routes column, they have the location column, which determines the parking location of each carrier. Next, we have the train route points. This sheet contains the latitude and longitude of the GIS points used to draw the paths over the GIS map as we have seen earlier. The same thing is for the vessel route points. Lastly, we have the colors sheet. This sheet is not used within AnyLogic, it just serves as a color catalog to use within Excel. Now let's run the model with a simpler set of data. We will simulate a cargo transportation system within the state of Kuwait. Let's assume we have 7 consolidation centers, as we can see here. 1 vessel path, as shown in red. 1 train path, as shown in blue. These green circles represent the circular regions we've talked about earlier, where the random orders will appear. Now that we have a general idea of the network layout, let us see how we can translate this into the Excel workbook. I have already prepared the Excel workbook for the new scenario, and I will take you through it. All that was needed to do is to update the sheets with the new data. We see that the consolidation centers and their properties are updated with the new 7 centers, as we've just seen. Accordingly, the origins and destinations are updated for the orders along with the desired arrival time and rate per week. The number of circular regions and their corresponding GIS points are also updated to reflect the green circles we've seen on Google Earth. In the random orders arrival rates sheet, the start time and rate per week are set for the different circular regions. With respect to the truck routes, here in this sheet we decide the number of desired truck routes. In this scenario, let's assume we have 2 truck routes only. We also assume that we have 1 train path and 1 vessel path. Moving to the truck route consolidation centers, we can see the new consolidation centers for each truck route along with the travel time and stop time. The same thing is for the train and vessels. For the vehicle schedule, we updated the departure time with respect to the route number and the transportation mode. For the trucks, in this scenario, we assume that we have 4 trucks, 2 in each route, 1 train, and 1 vessel. For carriers, we assume that we have 5 carriers, with the parking location specified for each. Next is the train route points. We've updated the GIS points to reflect the path we've seen on Google Earth. The same is for the vessel route. Now we've updated the Excel sheet. The model is already uploaded to the AnyLogic cloud. Now that we have the new Excel workbook ready, all we need to do is to upload it to the cloud and run the model. We can now see how the network layout and other model components have been updated. If we zoom into the Kuwait map, we can see the train path in blue alongside with the train, the vessel path in red alongside with the vessel. We can also see the trucks navigating to consolidation centers using the routes provided by the GIS map. Here we can see the parcels arriving at the consolidation centers. as well as random parcels appearing at one of the circular regions we have determined. We can also see the couriers moving to these random parcels to pick them up. So now we can see how our model can easily adapt to any scenario and update the network layout, its geographic location, and other components. Now for what we're currently developing in future work, we're working on some KPIs related to transport, some of which are the average transportation cost, the cost per kilometer traveled, and the capacity utilization. And with respect to the order management, some of the KPIs are order cycle time, the average cost of order, and the average CO2 emission and fuel consumption per order. We're also looking into some optimization models to plan a cargo orders route. That's it for this video. Thank you for watching.